So this should probably be a review for most of you. Pythagorean theorem pertains to a right triangle where one of the angles is 90 degrees. And first of all, the anatomy of a right triangle, the side that is opposite that right angle is called the hypotenuse. And in the traditional way of writing the Pythagorean theorem, it gets the letter C. The other two shorter sides, the hypotenuse will always be the longest side, are called legs. And they are, really doesn't matter which one you call A and which one you call B, but that is their letters. So A and B, B, you could reverse that just as easily. And Pythagorean's theorem, which you probably know already, is the idea that if you square whatever the hypotenuse is, that will equal the sum of the squares of the two legs. Cumbersome to say, but not too hard to write. Now, the idea here is that if you have two of these, you can always find the third, because there will only be one unknown. What I want you to be able to do is solve this for C without plugging in any numbers, and be able to solve for either A or B. It's really the same thing. So, for example, in order to solve for C here, I already have C squared by itself on the left. So what do I do to undo the squaring? Well, that would be the square root. The square root of C squared equals the square root of A squared plus B squared. Now, you don't have to write this step right here, because the point of taking the square root is to cancel the squaring, and I'll end up with just C. And so C is going to equal the square root of A squared plus B squared. Please keep in mind that you can't separate the square root sign, what's called the radical. You can't separate that and write this. This is illegal. You can't separate that across a multiplication like that. Across an addition. You can across multiplication, but not addition or subtraction. So here we solve for the hypotenuse. What if a problem gave us the hypotenuse and one of the legs? So let's say we were trying to find B. How would we go about solving this? Well, remember, once again, I'm not even worried about numbers right now. We're just going to go ahead and start with C squared equals A squared plus B squared. And the first thing we're going to do, if we want B, we got to move this to the other side. We're going to subtract A squared from both sides. So I have C squared minus A squared equals B squared. And just because I think it feels a little better, we're going to put B squared over here equals C squared minus A squared. Just switch the sides. And just like we did before, take the square root of both sides. That cancels this squaring here. And we end up with B equals square root of C squared minus A squared. Of course, A and B, like I said, are arbitrary. Like which one we choose to be A, we could have easily called the one that we call B A and vice versa. So for example, if you were looking for A, it would just be, there it is. Just reverse A and B. No big deal. But this is one way to look at the Pythagorean theorem. This is another way to look at the Pythagorean theorem. Same relationship, just reworked for a different variable. And of course, the original way of looking at it. So you can solve them explicitly. That means solving it without plugging in numbers, and then plug the numbers in. Or you can plug the numbers in and then do the problem. For example, here, let's just pick one that we already know. So let's say this is a 3 and this is a 5, and I want to know what side this is. All right. And the names are irrelevant. I could call this A, B, X, doesn't matter. The relationships are what's important. So in this case, I could take the 3 and the 5, and since I'm looking for one of the legs, I could just plug them into here. So I could say B is equal to the square root of 5 squared minus 3 squared. Or I could start from scratch, and I could start with C squared equals A squared plus B squared, and go ahead and just plug in. So 5 squared equals 3 squared plus B squared. And this would be 25 equals 9 plus B squared. subtract 9 from both sides, and get, let's see if we get this right, 16 equals b squared. Take the square root of both sides, and b would be 4. Meanwhile, over here, if I did it this way, if I solved the equation explicitly first with the letters and waited to put in the numbers, it would be 25 minus 9, and it would still come out to be the exact same answer, of course. Either way. But there are going to be plenty of situations in this class where you have to solve something explicitly. You have to solve it with the letters. You won't have numbers to work with. So we ought to be able to be good at that skill, which is why the one part of the summer assignment for this course is solving those equations explicitly. There's a bunch of different ones. Pretty much every one in this course I have you solve for various things. Okay, so try the problems associated with this and then move on to the next one.